Number 5, according to Master Foods, the company that manufactures M&Ms, 12% of peanut M&Ms are brown, 15% are yellow, 12% are red, 23% are blue, 23% are orange, 15% are green. Round your answers to 4 decimal places where possible. Compute the probability that a randomly selected peanut M&M is not blue. Not blue. Okay. How are we going to do that? What's the probability that a peanut M&M, a randomly selected peanut M&M, is not blue? Any ideas on this one?
You would add up all the numbers and then subtract 23% from the total.
You could do that. What do you think all the numbers might add up to be?
1?
Yeah, because they're 100%, right? So yeah, so if I said there's a 23% chance of rain today, then what's the chance it's not going to rain? How would you figure that out? If I said there's a 23%
77.
What's the chance it's not going to rain? What would we do?
77%.
Yeah, and how'd you come up with that?
You just subtract it from 100.
Just subtract from 100, huh? Well, that's exactly what we do with the blue, right? There's a 23% chance of getting a blue peanut M&M. So what's the chance of not getting a blue? It's 100 minus it, isn't it? See how the not idea means you subtract from 100 because it's the opposite, like rain and not rain, right? So the answer is just going to be 77%. The reason I don't need to bother adding everything up here is because I already know the total. If we're talking percentage, the total's got to be 100%. Now that's different than like the last question. See, this question wasn't percentages. It was just customers. So I needed to find out the total, 379 customers, and then keep dividing by the total, right? Because that was not a percentage problem. But on number 5, when you're talking about percentage, we know the total. It's 100%. It's 100% on that. Is that good so far? Is that making sense? Now, is that how they want us to do that question? And what I mean is, do they want a decimal? Does anybody know? Is anybody working on it right now? Do they want a decimal or do they want a fraction there? I mean, a percentage. Decimal or percentage? I'll check it out if you're not sure. Oh yeah, they want a decimal. Yeah, I just saw it. Okay, so they want us to say 0.77. Oh yeah, I should have read the instructions, huh? Round to 4 decimal places. So there we go. It's saying right there, round to 4 decimal places. So we good? So they actually want you to change it to a decimal, 0.77. Let's try the next one. Compute the probability that a random selected peanut is orange or green. There's that or word again. Remember, that's one of the main things this section is all about, and or, and the difference. So what's the chance you're going to get orange or green? What do we do in the case of or?
Add them together.
Add them together, huh? Because you can get orange or you can get green. 23%. Oops. Off track there. Add, and the green is 15%. So what is that? 38%. And then we've got to make it a decimal. 0.38. Good. All right. Let's keep moving. Compute the probability that 3 randomly selected peanut M&Ms are all red. Okay, things are gonna. I hope again. If I've been doing the Charlie Brown, the wah wah wah, dial in with me here. If you're doing your work and you're not paying attention, that's great. I understand. I would too. But right now, you're gonna really want to see this. This is a little tricky here. This is gonna be more challenging. They're saying red and red and red, aren't they? Isn't that what it means to get 3 randomly selected opinions are all red? It's red and red and red. So now we're talking about and. So what's the chance of red? Right up here, 12%. So I'm going to make it a decimal, 0.12, 0.12, 0.12. Now for and, we're going to multiply. That's the part I wanted to make clear to you. For and, you multiply. Or, so let me write this down. You're going to want this in your notes. Or we add and we multiply. See that difference? It's a really important difference that'll be really important on our next exam. So there is an important difference between and or. So or we add and we multiply. So take your calculator, 0.12 times 0.12 times 0.12. What am I getting? I'm getting 0.001728 when I multiply those together. Now, I'm supposed to round my answers, they told me, to 4 decimal places, right? Up here, 4 decimals. So 1, 2, 3, 4. So right there, I'm supposed to round the number. So it's going to be 0.0017. That's all we give. The 2 does not round up, does it? Just 0017. Okay, so and is multiply. Do you see that? That's pretty tricky. Or is add. And is multiply. That's an important difference that you need to be aware of. Yeah, and if it only said 2 red, what if it just said 2 red? Well, then I would just multiply 0.12 twice. If it said 4 red, then I'd multiply 0.12 4 times, right? Because every red is 0.12. The chance, every time you reach in the bag to grab out an M&M, there's a 12% chance you're going to get red. So the chance of getting 3 reds in a row is 0.12 multiplied 3 times. 2 times is 2 times, etc. However many reds, you multiply 0.12 that many times. We don't add. We multiply. Is that good? Now, I do not like doing math like it's magic. Like if I was you, I would be saying, why, Mr. Heron? Why in the world for or do we add and do we multiply? And the answer is because Mr. Heron says so. No, that's a lousy answer. Or the math book says so. That's a lousy answer also. I hope you're not satisfied with that answer. I hope you want to feel truth. I do. That's why I enjoy math. I like to see that it's true. It's nobody's opinion. It's true. So let me show you for just a second why multiplying is true for and. Why is that right? Let me ask you this. What if I said, hey, I'm going to flip a coin 2 times, right? What can happen when you flip a coin 2 times? You can get 2 heads, right? You can get a head, then a tail, or you can get a tail on the first flip, then a head, or a tail and a tail, right? When you flip a coin 2 times, aren't those the 4 different things that can happen, right? Head on both, head then a tail then a head, tail on both. Okay, why am I talking about coin flipping? I want to show you and. I want to show you the truth of and. It's not just some rule Mr. Heron said, but it's true. And you'll remember it better that way when you feel and understand the truth of it. Okay, so what's the probability that you get head and head? See, I made an and situation. What's the chance if you're going to flip a coin twice you're going to get a head and a head. Well, we can see the answer's got to be 1/4, right? Because there's 4 different things that can happen. Head, 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 tail, tail, head, tail, tail. And head is 1/4. Right? You could just see that's true just by looking at the different things that can happen. Let me ask you, how could you get that answer? What's the chance of 1 head? What's the chance of just getting 1 head? If you flip a coin 1 time, what's the chance of getting a head? I'm getting radio silence out there. Certainly you know the answer to this question. If I flip a coin 1 time, what's the probability of getting a head?
25%.
50.
Yeah, half. 50%, right? Good. So the chance is 0.5 or 50%, right? If you just flip it 1 time, right? So therefore, if you want 2 heads, right, head and head, I'm saying it should be 0.5 times 0.5. Does that make sense? Is that true? What is 0.5? Use your calculator. 0.5 times 0.5 is 0.25. That's the same as 1/4, isn't it? Do you see? I'm just showing you it's true. Do you see that? I don't know if that was very satisfying for you. I'm hoping you see that multiply is true in that situation, right? We know that the chance of getting 2 heads when you flip a coin twice is 1/4. We can see it because there's 4 different things that can happen, but we can also figure it out with the multiply rule. I'm showing you the truth of the multiply rule. See how wrong it would be to add? What if I had added 0.5 and 0.5 instead of multiplied? What would you get if you added 0.5 and 0.5? 1.0. That's not right. There's not a 1% chance or 100% chance of getting 2 heads. That would be crazy, right? That's not true. Instead, you've got to multiply 0.5 times 0.5 to get 0.25. So and clearly means multiply, doesn't it? Head and head, 0.5 times 0.5, 0.25, which is the same as 1/4. You guys know a quarter is 25 cents, right? 0.25 is the same as 1/4. So we know it's right. There is indeed a 1/4 chance of getting 2 heads. So it's true. The multiply rule is true. The add would be wrong. You could just see the truth of it, right? At this point, somebody needs to say, Mr. Heron, that's beautiful. I can see that so clearly now, or I'm just not going to be able to move on. I'm just kidding you. I'm mostly kidding you. You don't have to say that. I'm hoping you feel that to some degrees anyway. All right, I'll move on because I so much want you to feel the truth of these rules, but I don't want to waste too much time. We got other problems, so I better move on. But it's true. It's true that and means multiply. So make sure you remember these rules. Or is add, and is multiply. Let's finish up. We got 2 more parts here, D and E. So part D. If you randomly select 4 peanut M&Ms, compute the probability that none of them, I can't even read that there, let me get this here, that none of them are brown. Oh, none of them are brown. Ooh, that's not easy. Not easy at all. So none of them are brown. So what are we going to do? Well, we need, what has to happen to get 4? I got 4. You might have a different number. That none of them are brown. You've got to get not brown. On the right, you got to reach in the bag and get one out that's not brown, and reach in the bag again and get another one that's not brown, and reach in the bag again a 3rd time and get another one that's not brown, and reach in the bag a 4th time and get one that's not brown. Can we agree on that first off? If you're going to randomly grab 4 peanut M&Ms and you want none of them to be brown, that means you've got to get not brown 4 times. What's the probability of 1 time getting not brown? Just 1 time. If you're going to reach in the bag just 1 time, what's the chance you're not going to get a brown peanut M&M? Remember, that's the rain, not rain. What's the chance of a brown M&M? On my problem anyway? 12%, right? 12% are brown. So that's like saying there's a 12% chance of rain. What's the chance it's not going to rain or not going to be brown? You've got
88.
100 minus the 12, right? You good with that? Remember the rain, not rain. So whenever they say not something, you've got to subtract from 100, don't you? Whenever they say not. So that leaves 88%. So if there's a 12% chance of rain today, there'd be an 88% chance of not raining. So if there's a 12% chance of brown, there's every time you reach in the bag, then there's an 88% chance you will not get a brown. Okay, great. So what? Well, now we know each of these not browns is 0.88. Right? Every time, every time you reach in the bag, there's an 88% chance you will not get a brown M&M. And now what am I going to do with these 4 0.88s? Am I going to add them or multiply them? And means multiply.
Multiply?
Yeah. And is multiply or is add. So you take your calculator, take 0.88 times itself 4 times, or you could use the power button if you happen to know about that. Don't worry about it if you don't. I'm getting, what did I get? I got 0.599695. We're supposed to round to 4 places, right? So I put my line right there, and it's 0.5997. 5997. There it is. There's the chance 4 in a row, not brown. I just did not brown times not brown times not brown times not brown. If you only had 3, if your question said 3 in a row, not brown, then you would just multiply 0.88 3 times. Good so far? Questions on that one?
Yeah, I have a question.
Yeah.
On the question, what if instead of saying none of them, it just says neither of them? Would that just be the same thing?
Yeah, right. If you just have 2, neither of them is the same. Yeah.
Okay.
Quick question. At the end of when you get 0.88 times, or after you do that, do you divide it by 100?
No, we don't need to. We don't need to because we're dealing with percentages. 100% is the same as 1.0 decimal. So we don't need to. So I just multiplied the decimals, notice. 0.88, 0.88, 0.88, 0.88. So we don't need, because the total on the bottom, let me make sure you understood those phrases. The total on the bottom is 100%, right? Did you know that's the same as 1.0 decimal? How do we know? Well, how do you turn a decimal into a percentage? Like how do you turn, let's say, 0.37 into a percentage? You move it twice, don't you? Right? If you had here, let me make sure this is clear. If you had 0.375 and you want to make it a percentage, you'd move it 2 places and it would be 37.5%, right? Percent has 2 zeros. That means 2 places of movement. So 1.0, move it 2 places, is the same as 100%. Okay, so what? Why am I going on and on about this? Well, because if you divide, so 100% is 1. So if you divide by 1, nothing changes. That's why we don't need to do it, right? If you divide by 1, you're just dividing by 100% is dividing by 1. That won't change anything. Good question. Other questions on this one? Let's wrap up E. If you, I'm just having a little trouble reading it there. Let's see. If you, it's clear. If you randomly select 4 peanut M&Ms, could probably that at least one of them is brown. Oh, unfortunately, this is the hardest question of all. The key issue here, what makes this one so challenging, is that they say at least one. We're going to do a bunch of these at least one things in this chapter today, and then especially next section. These are hard for students. I know I keep saying that, but I want you to be eyes open, not surprised. This is tricky, and it's going to take hours of your life. If you don't give it those hours, it won't give you a good grade. It's hard. It takes time. Now, I put it in the notes. To help you out, I put it in the notes. Let me show you. Let me go back to the notes real quick and show you what I'm talking about. The exam 2 notes. Here it is. It's down here. It's number 3. So if you look on the exam 2 notes, there it is, at least one. I'm giving you an example. For 4 children, what's the probability of having at least one girl? And it says the opposite is having no girls. So the answer is 1 minus not girl, not girl, not girl, not girl. So I'm giving you an example of how you handle at least one. You do the opposite. You do 1 minus not. All right, so I'll leave that on the notes. Let me go back and explain that to you more slowly and carefully. Okay, so let's take a look. So they're saying, what's the chance that at least one of them is brown? At least one. So what does that mean? First off, let's be clear. At least one brown means one or more brown, doesn't it? At least one brown means one or more brown, right? Okay, so they're asking us, what's the chance that if we reach in and grab 4, you might have a different number, 4 peanut M&Ms, that we get one or more that are brown? Well, that's hard to do. You've got to think about the opposite. What's the opposite? What is the opposite of one or more brown? What if somebody said, hey, Mr. Heron, when you grabbed out those 4 peanut M&Ms, did you get one or more that are brown? And I say, no, I got the opposite. I did not get one or more that is brown. What does that mean, real life? I don't mean fancy math talk. I just mean real life. Math is supposed to represent and reflect real life. So just real life here. If somebody said, hey, Mr. Aaron, did you get one or more brown? I said, no. What does that mean? What happened?
You didn't get any?
Exactly. I didn't get any brown, right? The opposite is 0 brown or no brown, right? Good so far? I'm gonna lead you logically here. I want this to make sense. You'll remember it better. It makes sense why that formula that we just saw is going to work. It's the opposite, right? What is the opposite of getting one or more brown? Well, it's getting no browns, right? Isn't that the opposite? Okay, great. So what? I see that's helpful. Well, how do we always handle opposite? We take 100% minus for opposite. I'm running out of room here. For opposite, right? If the chance of rain today is 30%, the chance it won't rain is 70%, right? You opposite, you always do 100% minus. Well, 100% is the same as 1.0 decimal, as I was just saying a minute ago. So now let's change to the decimal, since they want a decimal answer on this one. So 100% minus for opposite becomes, in the decimal version, 1.0 minus. Minus what? No brown, right? That's the opposite. Here, let me do this. Let me add a blank sheet for us. Be a little easier. So, so the opposite is always 100% minus. And so in decimal, that's going to be 1.0 minus. And what is the opposite? No brown. So they're asking me, what's the chance that you get at least one brown? Well, the opposite of it is that I would get no brown. So if I take 100% minus the chance of no brown, that'll equal one or more brown. Are you with me? Am I losing you? Does that make sense logically? Right? If the chance of no, if they want the chance of one or more brown, we've got to do it by taking 100% minus the chance of no brown, because that's the opposite of one or more brown. Right? Just like, think about the rain. If you're getting confused, think about the rain. What if I say there's a 0.30 chance of rain today? Then that's 1.0 minus 0.70, the chance of no rain. You see how that's the opposite? Right? 1.0 minus 0.70 is 0.30. No rain, rain. Opposites. That's exactly what I'm doing with the brown M&Ms. It's right over here. It's rain, brown. No rain, no brown. Same thing, right? You know this is true, right? 1.0 minus 0.7. The chance of rain today is 0.30. Then the chance of no rain is 0.70. And 1 minus that is the 0.30. That's how you deal with opposites. Okay, so far so good. Now, coming down here, then I've got to figure out the chance of no brown. So the chance of one or more brown is going to be 1.0 minus the chance of no brown. And what's the chance of no brown? Well, how many we pull in? 4. We're no brown on 4 M&Ms. Right? What's the chance you're going to get no browns? Well, remember, we already learned how to do that, no brown. It's just like right here. Not brown, not brown, not brown, not brown. It's 0.88 every time. Right? Because there's a 12% chance. 12% chance that it's going to be brown. So not brown is 0.88 times 0.88 times 0.88 times 0.88. Now, it might help you to know, let me show you where I got this. If you look at the formula, it's 1 minus 0.12 times 1 minus 0.12. Whoops, I'm sorry, I'm writing too big here. Let me make this smaller. Like that, so that's 1.0 minus 0.88 times 0.88 times 0.88 times 0.88. That's what the formula says on your note sheet. It says to do one or more brown, which is the same thing of at least one brown. At least one brown means one or more brown. You do 1 minus, it says you do 1 minus the opposite of each of those, right? That's what it says on the note sheet I gave you. So let's do this on our calculator. And when I do that whole thing, I'm getting 0.4003, rounded to 4 places. 0.4003. So there we go. We got it. That is a challenging problem. Questions I can answer on that one?